Welcome to another video on my Raspberry Pi 1 running Raspberry and Linux, and I'm trying to get some analog sensors, or one analog sensor running on the Raspberry Pi. Now you can see, if you've watched my previous videos, some differences. One of them is, well, I have here another camera view, and that camera view is actually an oscilloscope. I'm trying to use it, getting familiar with it. It's brand new. And apart from that, well, it's in the view of right now not so very much delayed Raspberry Pi cam view, but experience has shown that when the program starts running, this view gets seriously delayed, and then of course this view, which is hardly ever delayed. Status of last week was that I got everything working. Well, not everything. What I did get working was the tiny light dependent resistor with a 10k resistor, all wired up. And what happened? Well, a zero value and pulse width modulation working. The fischertechnik LDR is not connected, as you can see. So let's check. Yeah, that's connected. So let's see whatever happens. Oh, by the way, this is not yet connected, so let me, and now I need this view. This is the scope connection, the mass, and I want it to connect to right. So if I remove this, it's flat, I touch it. So this is proof that it gives some value. Then and the program isn't running yet. So what happens when I cover this up? Absolutely nothing. Nothing at all. Alright. Well, it is through resistor connected to power. So you may ask, is this indeed alright? And the camera is off. Something is not quite correct now. Severely delayed. Oops, and there goes. That is not this is not good. I have to start my VNC viewer again. That is, but this is not alright. This is far from alright even. What is going on here? This is a big ouch. I have to log. I have to relog in. This is not good. Something happened to the Raspberry Pi. Big ouch. Alright, I'm back. It seems that the Raspberry Pi had completely reset. So I had to set everything again. Well, reset is actually rebooted, and I could tell because of the process ID of the VNC server. In Linux terms, you get the process number, and actually the process number of the new VNC process was lower than that I earlier had to handle, and that can only be when it's reset, reboot. Anyway, back to this situation. Let me move the game a bit. So it clearly shows that there's signal. But it's a solid value. And the point is, when I start the software, what will it do? Look at this. Last time I got all 0. Now I have a very nice value. So this means that my LDR is working, and looking at this, you see the LEDs blinking, so pulse width modulation is working well. And this is being a high strain on the Raspberry Pi. A very high strain, because it is sending the streaming image over the network to the VLC player, which is running on my laptop, and then it is running the editor, which I'm not doing anything. These images are running via my laptop, so not via the Raspberry Pi. I think that would cause an immediate crash. And then this program. So if I now cover once again the LDR somehow, what will happen with this value? I'm really very curious on that. So I don't see any change, by the way. Touching 900, and now I'm moving. Well, yeah, okay, it is 880s. But the oscilloscope isn't showing much difference. See, now it goes to 900 value again. And going back to 880. So there is a difference. The only thing is, the scope doesn't show any difference. So I probably will have to adjust the scope image to a more refined setting. Then again, I also have this one. What will be the effect if I connect this one to it? Will it be better? Will it do anything at all? That will be nice to see. So I'm going to set the oscilloscope to a finer setting, and then this one. Yes, good idea. Now before I replace this LDR by the fischertechnik version, which is already wired, I want to look at values that I've set on the oscilloscope, and then you notice something. When I cover the LDR, there's only one value that changes. Oh dear. And that value is VPP. Now I uncover and it gets 600, and I cover and it gets 1.2. Well, if it is alright. That is, let me open a network stream again, which hopefully works. Right now everything is stalled because of the camera. This is a big oops. Again, the camera takes a lot of resources. And if you take a look here, this is not blinking anymore either. And the whole Raspberry Pi is delayed now. So what I am going to try to do is stopping the stream, but that can't be because it is delayed. Hence a problematic situation. The lights are even constant burning with the bare eye. So now everything that goes on, let me try the LDR again. 1.2 microvolts and 600 microvolts, and this is 1.2 millivolts. So actually, really, it's really hanging. But to get back to this value, this is hanging because of, well, the Raspberry Pi, but this is still going on. So because this goes just straight to the oscilloscope. So the VPP changes, and I'm still looking right here. This is 1200 microvolts and this is 600 microvolts. And with an ordinary multimeter that I usually use, you can't watch it. So in comes, luckily, the oscilloscope. And this is still completely stalled, so I can't do anything. What I can do maybe is pressing Ctrl C, but given the delay, and clicking on this has no result. So I think that I have to quit using the live stream, because this takes way too many resources. Well, right now anyway. And both camera images are outside the Raspberry Pi. They're straight from the computer. So let's wait and see. Now, to check out the difference between this LDR and the fischertechnik version, I don't have to wait until the Raspberry Pi comes to life again. I can just replace this LDR, and now you see that everything is well, the level is back to 0, and I am replacing this one by this is the plus, this is the minus, so what's the difference? And there definitely is a difference, because when I look at the oscilloscope it now says 590 microvolts, and when I cover it, it stays this way. It just says 590 microvolts. There are some values changing, but not what I had expected. Ah, look at that. I don't know what has gone. Okay. Everything is gone back to normal. Wait, that's logical. I am not measuring anymore, so let me measure. Now I should be measuring things again. And this is also back to normal. So now let me see again. So now it is 120 microvolts. Am I measuring the correct thing? Yes, at the exact same place. This is, well, it's not different. Not different at all. VPP is still saying 120, but I'm still covering it, so there is something wrong in my understanding. Question is what? Well, the changing of the VPP obviously has nothing to do with removing my finger or not, removing my thumb or not. I do see one thing. When I remove my, let me show you on camera, that is much more convincing. Look at what happens at the oscilloscope, or should be happening. Alright, something was happening anyway. Some flash to 0, but even that is not happening anymore. Strange how you notice things, and it is not working anymore. Alright, let me try to get the stream back, which is much nicer. It fails, so that may mean that this is failing as well. Yes, it has completely killed. And by the way, let's see if this value has an effect on it is now 60 something, back to 6 or so, 200. Look at those value differences. So I still have to master the oscilloscope apparently, but this is a very nice result in view when it comes to this LDR. Although not entirely consistent, but nice to see. So let me put the other one back. Alright, I connected the other LDR again and see what happens now. Uncovered gives a low value, covered gives a high value. So for some reason I forgot to show you. Covered up gives this value, uncovered gives a low value, but it's a higher value than with this one, because this one was in the range of 0 to 10, and this one is clearly in the range of 20 to 30. Now I'm covering, now it's over 100, uncovering, it's 20s again, so they are different LDRs. And this clearly proves that the ADC is quite well working. Now with the wiring that I corrected last time, working very nicely. So question is, should I reinstate the camera stream? Let's just do it, get all and let everything working again. Sure, let's try. Is there something I can do with that oscilloscope? Nice try so far, but now the minimum voltage, which is here, is saying 0 volts, and that wasn't like earlier. Also it's now saying 590 microvolts. So let me check on, when I cover it up, what happens. I see no real value changes. Uncovered, and here you can once again see So I wonder what is wrong, if anything. With the value. By the way, that's interesting. It says 0. Okay, look at that. Hold on. In or min. Is it minimum voltage or maximum voltage? Yeah. Still things to discover. New devices? You never know. Anyway, this is nice. Unfortunately, I can't use both at the same time. And yes, let's reinstate this stream again. Get this working again. Why is that? Clear. Close. Maybe because it is still working or still starting. Now it goes. Very good. So actually the camera angle here is not showing the full view, of course. Doesn't show anything, but it is delayed anyway. Let me replace it once again. And now I do have to would it matter? Would it matter if I put the green one in first? It's an LDR, it shouldn't matter. It should not matter at all. So let me just do it like this. Put the probe on, like this one, and see whatever happens. So I'm covering it up. It says 1 into the 100. Uncover it, and yes, below 10. So this clearly shows there are two very rather different LDRs. The point is, you can actually combine them, just like two normal resistors. You can add them up. Would that be an idea? Interesting question. And easy to do. Alright, final part of this video. I am going to put the other LDR in as well, but I do have to change the setup a little bit, because the wires should not be in the same lane. So I have to remove this one and put it, for example, next lane, and then this one, let's say, mind the wires. Yeah, like I said, mind the wires. Why is it not cooperating? It is not cooperating at all. It's not sliding in smoothly. And I wonder why. Now it is. Now it is. Alright. Let go of this one. And now you see the huge delay between this video and this video. Actually, the huge delay of this one. I'm wondering when this one starts, when this one starts to show that accidental move. Let's just see whatever happens. So it's now the combination of the two. Right now it's in its 80s. Now it's well into 100. Releasing those both. They're in their 20s. Covering one. 50s. Covering the other. Uh-oh. I experienced an oops. Completely stalled again. This is not good. So I think for future use I should be not so actively using the Raspberry Pi cam. This is taking too many resources. Anyway, this has been a very nice experiment in more than one way. Connecting up a real oscilloscope, trying two LDRs which turn out to be different in measuring, and unfortunately rebooting Raspberry Pi and 2 times stalling. Look, minutes ago that happened, this movement, minutes ago. So much for a live cam. And there it goes again. Once again, covering one into the 60s, covering the other into 100, 99, uncovering both 20s, covering the one and covering another, uncovering both. Yeah. Anyway, that's what I did. Thank you for watching. If you like this video, please subscribe to my channel or follow me on Instagram, on Twitter. If for any reason you don't have accounts on either, just bookmark my website. On your browser, visit my website every week and you will see every video in my blog. What's more to say, please donate to keep my videos coming your way. More information on my website, and also pictures and other videos on my website. And this is to be continued, obviously. Bye bye.